yeah.
Oh, all right. I guess we're going here. Okay, so the states of matter, that's what we're talking about here.
States of matter? What's that?
States of matter. Matter, like that. Y'all remember what matter is, right? Yep. Anyone confused about matter? So matter is all the stuff around us that we can touch. So it's solids, liquids, and gases. That's all matter. The air is matter. The water in your bottle is matter. Anything you can touch is matter. Okay. So who remembers what the states of matter are? I gave you a big hint.
Solid, liquid, and gas.
Solid, liquid, and gas. Okay. Solid, liquid, and gas. Okay, so the easiest way to understand the states of matter is to look at the actual molecules of the states. Okay. So who remembers what the molecules of a solid look like?
They're all together, but they're shaking, they're vibrating.
Okay. Anyone else have anything to add to that? That's a pretty good starting point. So yes, they're all together. They look like this. They're not exactly touching, but they're very close. Okay. So so one of the important things is that they are attracted together. Like when you hold a solid, it doesn't just explode and go into a million pieces. You know what I mean? It all stays attracted together, so it's held together. They vibrate but don't move around. Around. And it forms a repeating pattern, okay? So you can see here, what's the pattern look like on this solid?
A bunch of dotted lines.
Yeah, so it's a line this way, a line that way, a line up and down. It's a nice repeating pattern, okay? Now, what do the molecules look like on a liquid? Let's get someone who's not Gigi.
They're kind of spread out, but not too far.
Kind of spread out. Belle, did you have something else you want to say?
No.
Yeah? So they're spread out a little bit more than with the solid. Do they form a repeating pattern?
Yes, it does. Actually, it just contains the shape of the container.
That's true. Yeah, so goes to the shape of the container. It's the container. And what's that called when it does that? Starts with an F. It's called a fluid. Okay. Anyways, they're kind of close. Do they move around?
Yeah.
Yeah. So they vibrate and they flow around each other. Okay. Around. And what was the last one? Oh, and then if you have like water in a water bottle and you pour it on your desk or something, does it just all of a sudden fly all over everywhere into the air?
No, it spreads out.
Yeah, it spreads out on the desk, but the water is attracted to other water molecules, so it likes to kind of clump together, even though it does spread out over the desk. So it's held together. Okay, finally, gas molecules. What do those look like?
Guys, those are all over the place.
Spread out everywhere? Are they close together or far apart?
Far apart.
Far apart. Okay. Do they move?
Yes.
Which direction?
All everywhere.
All over the place. They're flying all over the place. They're just kind of crazy. Okay. So are they held together at all?
No.
They're not held together. No attractive forces. Could you ever just like hold some gas in your hand like that?
No.
Pretty much no. There's some types of gas that are really heavy you might be able to, but yeah, it flies all over the place. Okay. Do they go to the shape of the container they're in? So for instance, if I had some gas and I put it in my water bottle, would all the gas just be to one side on the bottom? Or to go?
Everywhere.
Everywhere. So it would be the shape of the container, which is called what? Starts with an F? Fluid. That's exactly right. So it's a fluid. And then, yeah, they're just moving all over the place, I guess is the next thing. Okay. So, those are your states of matter. Now here's my question for you. So we know that thermal energy is vibration, okay? And as the molecules vibrate more, do they get spaced apart more or go closer together if they vibrate more?
They move away, but then they go back together.
Yeah, so if they're vibrating a bunch, they can't be very close to each other, right? They're going like crazy all over. So let's say you had a substance that was a solid, and then you increase the heat of that solid. So you're increasing the heat, and these molecules are vibrating more. Are they going to start spacing apart a little bit? Yes. Yeah. They're going to start spacing apart more and more and more, and pretty soon they're going to be so spaced apart that they're not going to want to stay in their repeating pattern anymore. They're not going to want to like be stuck exactly where they are, like solids usually are. And so it turns into a what?
A liquid.
A liquid. Okay. And let's say you keep increasing the heat. So these start vibrating more and more and more. And then pretty soon, these get further and further apart. And pretty soon they don't want to be held together anymore. They don't want to stay touching each other, so they want to fly out apart everywhere. And so it turns into a what?
Gas.
A gas. That's exactly right. So one of the ways you can move between the states of matter is by increasing the temperature of each of the states of matter, or decreasing it if you want to go back down. Okay. So one of the things you're going to have to do in your project is draw a diagram for each of these 3 states of matter, and then explain what happens if you add thermal energy to that state of matter. Okay. So remember, it's going to start vibrating more, and then it's going to space apart. And pretty soon, if it's a solid, it might turn into a liquid. See how that works? Okay. There's something else about your project I wanted to say. Yeah, so remember, on the project, I'm running out of space here. You have your fuel tank, and you want it to be a liquid, but when you park your rover somewhere hot, it evaporates into a gas. And then when you park it somewhere cold, it does what? Turns into a solid. And your commander is really bad at science, doesn't understand it. You have to explain the science to your commander, and then offer a suggestion about how you could keep your fuel as a liquid. So how you could keep it from getting too cold or getting too hot. Okay. All right. I think that explains.